Hey guys, it's Mr. Krieger. This is Unit 10, Lesson 6, Arc Length and Sector Area. Please make sure you print up the lesson. Okay, so before I read anything to you, let me just let you know what we're going to be working on here. We're going to be working on the lengths of arcs and also the areas of these portions, like the pizza slice, okay? But in order to do that, we need this fact. We need the fact that all circles are similar. Small circles and large circles are all similar. And since they're similar, ratios of corresponding portions of circles will stay constant. That means we can set up proportions, and here's going to be the proportion, okay? Now, we learned how to find the degree measure of arcs in not the previous unit. It was actually in a previous lesson, like lesson 1, I believe, where we actually talked about like how a central angle is equal to the arc here, right? But that's different than the length of the arc. Let me illustrate that by showing you an example. You see, here are two circles. Obviously, all circles are similar, and these are two central angles of 120 degrees. Therefore, this arc here is a 120 degree arc, and this is a 120 degree arc. But that's not the length, because that wouldn't make any sense, because clearly this length is shorter than this length, because this circle is bigger. Let me give you an example. We know a circle has 360 degrees in it. This is 120 degrees. If this circle had a circumference of 9, 120 is a third of 360, so this is a third of the circle. That length would be 3. Even though the degree measure of that arc is 120 degrees, the length is 3. Now over here, let's say the circumference of this circle was 18, double, right? This is 1/3. Because 120 is 1/3 of 360, it's a third of the whole circle. 1/3 of 18 would be 6. So just because the arc measures are 120 degrees for both, does not mean that their lengths are the same. Their lengths have to do with the portion out of the whole circle, and the size of the circle will matter. Okay, so taking a look at this example, actually, before we even do that, let me go to you've probably seen this piece before. This is the game piece from Trivial Pursuit. I put 5 yellow pieces and 1 purple piece here. We want to find the length of this section right here. How long is it to go from here to here, right? Well, there are 6 pieces in here. So if this whole circumference of this circle were, let's say, 6 centimeters, then that would be 1 centimeter around. I'm just using nice whole numbers so that they work out for us nicely. It could be anything. It can work out to be decimals, okay? So here's the proportion we can use. And this way you don't have to memorize, well, you'll memorize this, but you'll basically be able to use the proportion to solve all these types of problems. Now, in this problem, we want to find the length of this arc. So I'll put an X there. How long is that arc? Well, let's use the formula. Oh, and by the way, in the formula, we're going to need the circumference of the total circle, and you should know that circumference formula is 2 pi r. All right, so let's figure that out first. For this circle, the circumference is going to be 2 times pi times 7, or 14 pi. Now using the formula from above, I'm not going to rewrite it here, but you should always rewrite it. Using that formula, the central angle is 20 out of 360. That means as a portion of the whole circle, it's 23/60ths. If I reduced that, it should be about 1/9. It is exactly 1/9, right? I'm sorry, 1/18. 1/18, because 2 goes into 36 18 times, so this is 1/18. On the other side, we're going to get the arc length, how long that is, over the circle's circumference. And let me talk to you about the logic here. This is the portion of a circle in terms of its degree measure, 20 degrees compared to a whole circle of 360. This is the portion that talks about the length of that arc compared to the length around the whole circle, the circle's circumference. Once you have it set up, then you can cross multiply. You get 360x equals 280 pi. Divide both sides by 360, and you get 7/9. So this is going to be 7 pi over 9 is the distance around the entire circle. I'm sorry, that's a distance around this portion of the circle. The distance around the whole circle is 14 pi, and this piece right here is only 7 pi over 9, 7/9 pi. This is 14 multiples of pi. This is not even 1 full pi, this distance, okay? So now you kind of get the idea of how to use this formula. Let's try another problem. Again, it's the central angle over 360. That's the part over the whole, part degree over whole degree. And on the other side, we have the arc length over the whole circle circumference, 2 pi r. Okay, so putting in what we know, they're using, instead of x, they're going to use, so a lot of times they use theta to measure that angle. So we have theta over 360, that's like x. The arc length in this case we know. Here we're given the arc length. And what we're missing is the degree measure of the central angle. And for the circumference of the circle, it's 2 pi times 12, which we can replace with 24 pi. Now cross multiplying, actually before we cross multiply, we can divide out the pi's, make our life a little easier. And then when we cross multiply, we're going to get 24 times theta equals 360 times 8 is 2,880. Divide both sides by 24, and we get theta is 120 degrees. So this central angle here is 120 degrees. Okay? So that's how you find the relationship between the arc length, the radius, and the central angle. All right, let's go take a look at the next page. All right, so what we're going to do next is we're going to find the area of a portion of a circle. Now, you know how to find the area of a whole circle. It's pi r squared. We can put that formula right here. Area equals pi r squared. But that's not the area of a whole circle. That's the area of a portion of a circle. We actually have a name for a portion of a circle like that. We don't call it a pizza slice. That's a pretty big pizza slice there. We call it a sector. A sector is a region of a circle that's bounded by 2 radii, this radius and this radius, and the intercepted arc AB, and we actually name that sector AOB. Okay, so that's how it's named, using that angle, sector AOB. All right. Now look at this formula. It's very similar to the formula we just used. In fact, the left-hand side of the formula is exactly the same because it's part over a whole. A whole circle is 360 degrees, but this central angle is only a portion of the whole circle. On the right side, it's similar, but not the same as the other type of problem. The other problem, we were talking about lengths. Here we're talking about areas. Sector area is the part of the whole circle. And the circle's total area, pi r squared, that would be the whole circle. Now, coming back to our Trivial Pursuit game piece, again, if this whole area was 60 square units, then this purple piece would be 10 square units because it's literally 1/6. It's nice when it works out to be divided evenly like that. We know it's in 6 parts. We don't always know what portion it is. So that's why we really need the formula here. Okay, so here we want to find the sector area here, sector area AOB. We know the central angle is 130 degrees, and we know this radius is 6 inches. Right away, we should find the area of the circle, pi r squared, pi times 6 squared. And since we're leaving things in terms of pi, we could just leave this as 36 pi. And now we're going to use this formula, which I'm not going to rewrite here just because I don't have a lot of room. But again, on a test or on an assessment, you should write it, or even on your homework. Central angle is 130 degrees over 360, so it's a part of a circle over the whole in terms of the degree measure. And on the other side, well, we don't know the sector area, so we'll call that x. And we know the circle area is 36 pi, so this is simply the equation that you would use, the proportion you would use. Cross multiply, you get 360x, and this times this is going to be 4,680 pi. Divide both sides by 360. And you get x is 13 pi. Whereas the whole circle is 36 pi, This portion is a little more than a third. A third would be 12 pi. Well, this is 13 pi. Because if this was 120 degrees, you get 12 pi. 130 degrees would be 13 pi. I guess you could figure out what 140 degrees would be, right? Okay, so let's go on to the last page. So here are some sample problems for you to try on your own. And you can pause the video, you can try them, and you can check to see if you got them right. Okay, this one should be pretty easy. We could use the formula, but 60 degrees is what portion of a whole circle? It's 1/6 of a whole circle. So therefore, if you found the area of the whole circle, pi r squared, which would be pi times 10 squared, or 100 pi, then literally this would be 1/6 of the whole. You could divide this by 6. By the way, if you divide this by 6 and reduce, you're going to get 50 pi over 3. In other words, if you divide both these top and bottom by 2, 100 divided by 2 is 50, and 6 divided by 2 is 3. But now let's use the formula. Make sure it coincides, it justifies this answer. So we're going to do central angle over total, the total degrees of a circle, 360, equals, there's the sector area we don't know, over the rate of the area of a whole circle we learned was 100 pi. Cross multiply, and we get 360x equals 6,000 pi. Divide by 360. And if you reduce 6,000 divided by 360, guess what you get? You will get 50 pi over 3. You can check that on your calculator if you like to make sure it's the same. They asked us to leave this in terms of pi, so I did. All right, now you can try the next problem. We want to find the area of this sector. That's a little more than a third. So I don't want to do divided by 3. I'm going to use the formula. Let's find the area of the total circle. Again, pi r squared is the total area. Pi times 3 squared is 9 pi. Using the formula, we get a central angle over 360 equals the missing sector area over the total circle's area. Cross multiplying that, let me just make sure. Yes, so cross multiplying that, we get 360x equals 1350 pi. Divide both sides by 360. And you're going to get, it's 11.7089, 7809, I should say. And if you round it to the nearest tenth, the sector area is 11.8, approximately 11.8. All right, last problem. Here, the difference is going to be, let me read the question, you'll see the difference. In a diagram of circle O below, the shaded sector is 12 pi. They're telling us the shaded section. They want to find the measure of angle AOC. Now, you're welcome to put a theta there, or you could call it x. Some people like to work with x better, all right? So we could easily find the circle's area. Remember, circle's area is pi r squared, which is going to be pi times 6 squared, or 36 pi. Now, the sector area is 12 pi. The total area is 36 pi. So this angle should be 1/3 of a whole circle. What should 1/3 of a whole circle be? You might be able to answer that in your head, or you can go to the formula. Central angle over 360. Again, the central angle is what we're missing this time. We have the sector area, and we've just learned the area of the circle. We can divide out these pi's, cross multiply 36x equals 4,320. And we get that central angle is 120 degrees. Does that surprise you? 120 is 1/3 of 360. We knew that this area, 12 pi, was 1/3 of 36 pi. So the angle measure should be 120 degrees. It was nice that it coincided. All right, you should be able to work on your homework now.